Okay, hello everyone, it's Salar and we are in part 39 of our tutorial. A tutorial to writing a real-time operating system. We are in part 39 of our tutorial. In previous part, I've started to talk about linked list and data structures, okay? And I walked you through to create a simple linked list by C programming language. Okay, but in this part, I want to show you my implementation, my data structure implementation that I want to use and I will use in my RTOS, okay? I've implemented some data structures that I want to use in my RTOS. Okay, but before talking about these data structures, I would say the name of my project is OpenTeach project. Okay, here is the name of my project, OpenTeach project. And from this part, I will upload my codes to my GitHub. Okay, to a repository on my GitHub. And here is the address of my GitHub and GitHub repository. github.com OpenTeach project, OpenTeach project, without space. And here is the name of my GitHub and here is the repository of our project. Okay, OpenTeach project. If you want to find my codes and implementation of my RTOS and my codes in GitHub, you can go to this address. Okay, here is repository of my project, github.com OpenTeach project, another time OpenTeach project, my repository. Okay, and for example, in this time I just upload some file of my data structures in my repository. Here is directory of data structure. In that there are two other directories, subdirectories include that. In this directory we have linked list, the header file of linked list, queue, single linked list, and stack. In this part I wanted to talk about linked list and single linked list, and we'll get into queue and stack in the next part. Okay, here is include subdirectory in this data structure, and here is source, another time linked list.c and single linked list.c. And if you want to use these codes in your project, you can download from here, download zip, this repository, OpenTeach project, this directory, and add it to your project like here. For example, in Eclipse workspace, I create a project, my tutorial project, and in that I have the directory of my project that I've downloaded from my GitHub, OpenTeach project -master. Okay, and here I have, like in GitHub, data structure license written, data structure license written. Okay, and in data structure I have include and source. From this part, step by step, I will upload my codes to my GitHub. Okay, and my project is an open source project in GitHub, and you can use that, and you can use my project under GPL version 3 license. Okay, here is, I've licensed my project under GPL version 3. Okay, so if you want to use my codes, you can download this directory from GitHub and add in your project, and add it in your project. Other configurations to create a project are like before. Okay, let's go to Eclipse and do one other configuration to use this project. Okay, here is a project, and as you saw, I've added this directory in my project. Okay, I've downloaded this directory, this project from GitHub and add it to my project. And if you want to use the project, you just need to go to the configurations here and go to the include path of your C compiler and add this directory that I've added in my project in include path. Okay, the configuration is complete, and in this way you can easily use my project in your code. Other configurations are like before. Okay, very good. Let's go back to slides and talk about data structures. So the address of my repository is GitHub OpenTeach project, OpenTeach project. And let's talk about some other linked lists that I've implemented to use in my real-time operating system. One of that is singly linked list. Singly linked list. Here is a linked list just like a linked list that I've implemented in previous part. You have element and you have a pointer to the next node. But there are some difference between this singly linked list and the linked list that I've implemented in previous part. First, in this linked list, element is not an integer number, is a void star, is a pointer. Is a pointer to your element. So you can add any element in your node and in your list. On your node and on your list. And I have a key, an integer number in my linked list. Okay, and this key has some usages. Okay, and like before, just one pointer to the next node. Singly linked list means you have just single pointer to next node. Okay, as you can see, here is data structure, include singly linked list, and here is implementation of node. Just like before, I have an element, but here the type of element is void star, is a pointer to the element, a key that is an integer number, and a pointer to the next node. And in my list, I have nil node and a size, a pointer to nil node at the first of the list and a size. Okay, and here is the function of this list. Create a new node. By this function, you can easily create a node. You just give your element and key to this function as argument 1 and 2 and create a node. Create a list. Insert a node at the first of your list. Insert this node at the first of list. Delete first node of your list. You can insert a node after another node, okay, to this list. You can insert node X after node Y, and delete after. You can delete a node after delete X. This function delete a node that is after node X. You can search a node by its element, and you can search a node by its key, and you can get the size of your list. Okay, if you are curious about implementation of this singly linked list, you can go to source directory and see and study this file by yourself. The implementation is so easy. Okay, or you can study CLRS algorithm books, the book that I've recommended in previous part. Okay, here is implementation of singly linked list node. Okay, and here is a list that you create by this library. First you have nil node, and after that you have other nodes. But there is another difference than that linked list that I've created in previous part. In this linked list, the last node points to the nil node. Okay, it's another difference with previous linked list that I've implemented in previous part. Let's to see an example and using of this linked list in Eclipse. Okay, here is an example that I want use singly linked list to see you how you can use this linked list in your project. First, you need to add this header file in data structure include single linked list. Okay, include this header file in your file. Okay, after that, in my main function, I want to insert the three elements, three string in this time. Okay, string 1, string 2, and string 3. A pointer to string 1, a pointer to string 2, and a pointer to string 3. I want to add these three strings in a list. First, I've defined a list, my list, singly linked list, and defined three nodes to add these elements to these nodes. Node 1, pointer to node 1, a pointer to node 2, and a pointer to node 3. The type of node is singly linked list node. Underline underscore T. Okay, it's a type of node. Here is a type of list. After that, config my board. I've configured my board, and after that, create a list by calling this function singly linked list create new list without any arguments, and create a list. Okay, now I have address of my list here in this variable. After that, I've created my node and I've inserted my node in the list. First, node 1. By this function, singly linked list create new node. Create my node by this element, okay, str1, pointer to string 1, okay, and a key. For example, here key is 1. And I've added my node to the list and insert first of my list after nil node. Okay, I've added node 1 in my list at the first of the list after nil node. Okay, after that, I've created another time node 2 from this element string 2 and with this key 2. Okay, 2 as a key. But in this time, I've added my node in this way. I've used this function singly linked list insert after. I've insert node 2 in my list after nil node. This function is like insert first. Okay, so node 2 after nil node. Another time I've created node 3 by this element and this key, and another time I've added my node in my list. I have inserted node 3 in my list another time after nil node at the first of the list. After that, I've deleted a node in my list. I delete a node after nil node. Okay, I deleted a node after nil node. Delete after. I deleted a node after nil node. Let's debug this project and see the result. Okay, here I'm in debug perspective and I want to use this list. First, config my board, create a list and create node 1 and insert that at the first of the list. So here is my list. The size is 1 because I've added just one node, node 1. First I have nil node. After nil node I have a string 1 by key 1. Okay, I've added a string 1 in a node 1 in my list. Okay, here insert first after nil node. Let's do run here. Now I've inserted node 2 after nil node. My list size is 2, but in this time here is nil node by elements 0 and key 0, but after nil node this time I have node 2 with key 2. The key of node 2 is 2 and inserted after nil node. Okay, here is nil node, after that key equal to, and here is address of my string 2. Okay, 26 54, string 2 is 26 here, 2654 here. Okay, here. Okay, another time insert node 3 after nil node. Another time in my list the size is 3. After nil node I have node 3. Okay, so and do it a node that is after nil node. Now after nil node I have node 3, and by this function I will delete node 3 from list. Let's do run that, and another time see my list. In this time in my list after size is 2 and I have node 2 after nil node because I deleted node 3 by this function. Okay, and you can search a node by its element. For example, here I want to find node 2 by its elements. If I run this function singly linked list search by elements. Okay, in node here I have address of node 2 here 908, and in node 2 I have 908. Okay, I've searched this node and I've put address of node 2 in this pointer, and by this function from my board serial port transmit string I can print element of node 2. Print element of node 2 is a string 2 is 2. I can print this string in com port here. Let's do here qt.com, open that, clear here. If I run this function I have a string 2 here. Okay, in this way I can use this library in my project. If you are curious about implementation of this library, you can go here, data structure, source, and single linked list, and you can find the implementation. Implementation is so easy. Study that by yourself. Okay, let's go back to our slides. Here is the slides. So I have a single linked list and I can use this data structure in my operating system. But I have another implementation of linked list. But in this part, linked list has two pointers, a pointer to the next node and a pointer to previous node. Okay, this linked list sometimes called doubly linked list because in this linked list I have two pointer, a pointer to next and a pointer to previous. Okay, and like single linked list, I have an element that its type is void star, and I have a key, an integer number in my list. And here is the structure of the list. First, I have nil node from, for example, this node, for example, node 1. I have a pointer to the next and a pointer to the previous node. Okay, here is a pointer to previous node, and here is a pointer to the next node. And the last node point to the nil node, and nil node by this pointer previous point to the last node. Okay, in my GitHub, in this directory, include and linked list, I have implementation of my node and list. But in this time, I have another pointer in my node, a pointer to previous node. But list is just like before, a nil node and the size. But because of this pointer previous node, I can add a node at the first of the list and the last of the list. By this function, you can add this node at the first of your list after nil node, and by this function insert last, you can add this node at the last of your list, and delete first and delete last. And by this function delete, you can delete any node that you want. Just give the address of your node and delete that from your list by this function. And like single linked list node, here you have search by element and search by key function. Okay, and these two functions return you a node, and another function gets size of your list. Another time, if you are curious about implementation of this linked list, you can go to source file and study this file, linked list.c. Another time, there is a simple implementation. You can easily study that by yourself. And you can increase the options of this library by yourself. And you can contribute in my project. Okay? In GitHub, you can fork this project from GitHub and contribute to my project and help me to make my project better. Okay, but another time, let's to see an example of this linked list in Eclipse. Okay, here is the example. But in this time, I've added linked list in data structure, include linked list in my file. Like before, I want to add these elements string 1, 2, and 3 in my list. I've defined a list, a pointer to list. Here is a pointer, okay? Here is a pointer, and 3 pointer for my nodes. And I can use these variables to create a list. First, create a list by using of this function, by means of this function, linked list, create new list, and put the address of your list in this pointer, in this variable, my list, and create like single linked list a node 1 by this function, linked list create new node. The element is string 1, pointer to string 1, and the key is 1, and insert that in the first of your list. Okay, insert first. Let's do debug this project. Press this ladybug button and debug your project. Here is I'm in first line of main function. Configure board, create your list by this, create node 1. In this time I have not added any node to my list, so in my list I have just nil node, okay, and after nil node another time I have nil node, okay, but in this time I have a pointer to next node and a pointer to previous point, and size of my list is 0. Let's insert node 1 at the first of the list after nil node. Okay, here the size of list is 1. Here is nil node. The next node of nil node is node 1, a node by key with key 1. Here is node 1 with key 1. Okay, after node 1 I have another time nil node, and previous that I have nil node because I just have node 1 in my list. And create node 2, and by using of another time insert first, insert node 2 at the first of list after nil node another time. So the size of list is 2. After nil node, the next node of nil node in this time is node 2 because added at the first of the list. And after node 2 I have node 1, and here is my list. Okay, let's to create node 3, but in this time add node 3 at the last of the list after node 1. Insert last. Here is my list, size 0. The first node is node 2 like before, next node of 2 is node 1, and next node of node 1 is node 3 because node 3 added at last of the list, inserted last. Okay, and by using of this function let's to delete the last node. The last node is node 3. Run that. So the size of list is 2. Another time after nil node is node 2, and after node 2 is node 1, but in this time after node 1 is nil node by with key 0 because we deleted node 3, the last node from the list. Okay, like before, you can search a node in your list by its element or by key. There is another function to search by key. Okay, the string 2, I wanted to find string 2, the node of string 2 in my list. Okay, the element of node 2 is 2, this string. Okay, another time close and open, clear your terminal and run serial transmit string. I have a string 2 in my terminal. Okay, here was an example to see you how you can use this library in your code and in your project. Okay, but in the next part we will get into queue and stack, but in next part I will not implement queue and stack as a specific linked list. I create queue and stack by a linked list in next part. Okay, thank you very much to see me, and see you soon in the next part. Thank you very much.